Okay, this is this transformation sheet that we've been working on both first semester and second semester. Most recently, we did exponential functions back in chapter 6. So today we're working on quadratic functions. So our most basic quadratic function is y equals x squared. Now, we have actually already talked about the vertical translations. Let's jump down and do that. So we're on this row that says vertical translation down 3. So we saw that when we did y equals x squared minus 3. Up 4, we see y equals x squared plus 4. And then a reflection over the x-axis, we see y equals negative x squared. Okay, and then in terms of vertical stretches and vertical shrinks, a vertical stretch by 5 we see as y equals 5x squared, and a vertical shrink by 1/6 we see as y equals 1/6 x squared. Okay, let's find out about the others. So the others have to do, when we see them, is when we are in vertex form, which we're going to see coming up here. So this one says a horizontal translation left 1. And remember how when we did absolute values, we saw that inside the absolute value or inside the exponent on exponential? Well, so we see this inside parentheses, so it'll say y equals, and then in parentheses, x plus 1, and then outside the parentheses squared. Same thing with right. When we did horizontal, we even wrote down on the outside here that we see it as plus or minus on the inside. And so remember, we saw it on absolute value inside the absolute value bars, inside the exponential. So we're going to see it as inside the parentheses x minus 2 parentheses squared. And that means right 2. Remember how horizontal are kind of opposite, where minus means right and plus means left. And then a reflection over the y-axis, we even wrote down that we see the negative inside. So you're going to see it like this, y equals, and then in parentheses, negative x squared. And then the horizontal stretch, we talked about how it's multiplying inside, but you use the reciprocal. So instead of using 7, we're going to see y equals, and then in parentheses, 1/7 x, and then outside the parentheses, squared. And same thing for the shrink of 1/8. Use the reciprocal, and it's inside the parentheses. So you'll see it as y equals parentheses 8x, and then outside the parentheses squared. And so that will fill in our transformation sheet for quadratics. Let's go ahead and let's take a look at our notes that we're looking at. We are, sorry, let me get back there. Here we are. We are ready for graphing in vertex form. So remember, vertex form, we wrote this down in our vocabulary, is this. F of x, or y equals a times x minus h squared plus k, and your vertex is hk. That means your axis of symmetry is x equals h, and k is not your y-intercept. So remember back when we had standard form, y equals ax squared plus bx plus c, our c value was our y-intercept. That's in standard form. That's not the same on vertex form. So let's look at completing this. Okay, so first we're going to compare. We have the 1/2, it's outside the parentheses, so that is a vertical shrink by 1/2. And then we have the -4 inside the parentheses. That tells me it's a horizontal translation. Minus means right, so it moves right 4. So your vertex moved to the right 4. It didn't move up or down any, so it's 4, 0. And how I can see that is, remember that my vertex comes from h and k. Now, notice that h is right after the minus, so it's minus and then the h. So minus the h is just 4, not negative 4, it's just 4. And there is no number out here. You can think of it like a plus 0, and that's why the y value of the vertex is 0, which is where this k would be. So if you can get the vertex right, then you should be able to get the axis of symmetry right. Remember that it's always x equals because it's indicating a vertical line. You have to have x equals. The domain is all real numbers, and I'm going to wait to see it until I find out my range. So my vertex is at 4, 0. Look at the a value. The a value is in front of the parentheses. The a value is positive. That tells me it's going to open up. So what we're going to do is we are just going to go ahead and make a table. Sorry, I got those mixed up. That's 4, 0. And then I'm going to go ahead and plug in 5 and 6. And you can use a calculator to do this. So what I would be doing is I would be plugging in 5 for the x value and then 6 for the x value. All right, so if I plug in 5 for the x value, I'm going to go ahead and get 0.5. So 5.5. And when I plug in 6 for the x value, it'll be like this. It'll be 6 minus 4. So you will have 2. So I would really suggest you draw in that axis of symmetry so that when you reflect those points over to find the other point, you're in the right place. That really helps me not make mistakes. So there is my graph, and that's y for the range, greater than or equal to because it opens up, and 0 because you always use the y value of the vertex right there. All right, let's look at this one. So the negative on the outside of the parentheses is a reflect over x-axis. It also tells me it's going to open down. The +2 inside the parentheses is a horizontal translation. Plus is left, so it's left 2. And the +4 on the outside is up 4. So that tells me that my vertex, you look at this number right here. Remember, normally it's minus. It's like this. This would be the same as x minus -2. And so if you look, after the minus would be -2. Isn't minus and negative the same as plus? So another way you can think of this is instead of thinking of it as 2, think of it as the opposite. It's -2. Versus this one doesn't change. It's +4 and you use a +4. So you can also think of it that way. So my vertex is -2, +4. Or think of it like your vertex used to start at 0, 0, but then you went left 2 and up 4, and that would be at the point -2, 4. Your axis of symmetry is x equals -2, and let's go ahead and draw that in. All right, it does open down because of that negative. So we're going to make a table. And so I'm at -2, 4. So I'm going to plug in -1 and I'm going to plug in 0. And honestly, I'm just going to use my calculator. I type it in exactly like you see it there with the parentheses and everything. All right, so I got 3 when I plugged in -1. And then I'm going to plug in 0 and I got 0. So it has a point at -1, 3 and 0, 0, and then you can use your axis of symmetry to reflect your points over. Remember, you need a vertex clearly marked, plus 2 points to the right and 2 points to the left clearly marked. Okay, your domain is all real numbers, and your range is y is less than or equal to because it opens down, and 4 because 4 is the y value of the vertex. All right, this is example 2 continued. So comparing, we're going to have a vertical stretch by 3. The -1 is right 1, and the -6 is down 6. So think about your vertex. If you move right 1 and down 6, your vertex is at 1, -6. And I see that because the -1, remember I told you you can think of it as after the minus is the h, so it's a 1. And then the k is out here, so it's -6. Your axis of symmetry is x equals 1, has to be x equals, or it will be counted off because you have to have that x equals to tell that it's a line. All right, it opens up because the a value is positive. It's just a 3, so you know it opens up. And so I'm going to go ahead and I'm going to plug in 2 and 3 and see what happens. And totally use your calculator just to type it in. So when I plug in 2, I get -3. And when I plug in 3, I get 6. So 2, -3, and 3, 6. And then you can reflect those over your axis of symmetry, which is why we drew it in. It's pretty steep because of that 3. Remember that 3, that vertical stretch, is what makes it so skinny and steep, kind of hard to draw in. Your domain is all real numbers, and your range is y. it opens up, so greater than or equal to, and you use the y value of the vertex.